In this video, we will learn about the decision tree, which is widely used in artificial intelligence classification models. We will explore how it works and take a closer look at a coding file to understand it better. First, before explaining the decision tree, let's understand regression and classification. As mentioned in one of the previous videos, in artificial intelligence datasets, we can use not only numerical data, but also categorical data. Numerical data refers to data that is a continuous and measurable range of values, such as price, weight, or temperature. Categorical data, on the other hand, is represented in the form of categories or labels, such as gender, color, and type. While categorical data can be represented numerically for computers to understand, it does not have numerical significance such as larger, smaller, or equal. When building an artificial intelligence model, if the dependent variable y is numerical, we aim for regression, and if it is categorical, we aim for classification. Therefore, we use the iris dataset where the species of iris is the y value for classification. Decision tree is one of the artificial intelligence models capable of both regression and classification tasks. It is shaped like an upside-down tree, and the squares that contain questions or answers are called nodes, which are connected each other by branches. The principle of the decision tree is similar to playing a game of 20 questions, where we narrow down the target by asking yes or no questions. In this slide, we classify based on the concepts of greater than or less than, using split variables x1, x2, and split points a1, a2, a3, etc. When a new yellow point comes in, it is classified into the group to which it belongs. In other words, the new point is classified into the G2 group and becomes green. In the case of regression, the prediction is made based on the average value of the corresponding region. If the new point belongs to the G5 group, and the values in the G5 group are 1, 2, and 3, the prediction will be the average value, which is 2. This slide shows a coding screen that applies the decision tree to the iris dataset and builds a classification model. By the way, the Jupyter Notebook file is available on GitHub, so you can download it and run it yourself. First, we need to load the Excel data that we worked with in the previous video, set the X and Y data, and then split them into training and testing data. In order to use the decision tree model, we import the decision tree classifier library. Additionally, we import the metrics library for evaluating the model's accuracy. As mentioned in the previous video, remember that if you encounter an error stating that the library is not found, you can use the pip install command to install it. Also, please be mindful of the case sensitivity in Python, as it distinguishes between uppercase and lowercase. After importing the decision tree library like this, we create a decision tree model with a max depth of 3 and store it in a variable called dtree. Here, the max depth is a variable that we can manually set in machine learning, known as a hyperparameter. It generates a tree structure with these 3 levels. Then, we train the model using the X and Y training data by using this simple line. Afterwards, we input the X training data into the constructed model and store the predicted values. We also repeat this same procedure for the testing data. Next, we compare the predicted results with the actual Y values and determine how accurate the predictions are. We use the print command to display the accuracy, and you can use the dot followed by the number to adjust the decimal places in the result. In this case, using 0.3 will display the result up to 3 decimal places. Let's summarize this process. We divide the data into training and testing sets, then train the decision tree model using the training data to build the model. Afterward, we apply the same training data to the model to assess its accuracy. The training accuracy is found to be 0.992, indicating that it correctly predicted the species with an accuracy of 99.2%. Additionally, when the testing data is applied, the accuracy is measured as 0.933, meaning that it accurately predicted the iris species with a 93.3% accuracy rate. Of course, it is important to undergo further validation processes to ensure the accuracy of these results. However, since this is your initial experience with using artificial intelligence models, the focus was placed on understanding the coding process for building the AI model. In the next video, we will introduce you to other artificial intelligence models.